My name is Russell Clegg and I work with Agilent Technologies, soon to be Keysight Technologies. And today I want to talk about our new family of AC sources, the AC6800 series AC source family. And one of the measurements that you're able to make with this is peak inrush current, which is a figure of merit for most power supplies and is very helpful in production to make sure the unit's been properly designed and properly built to make sure all features are operating correctly. So today I'm actually going to test one of our own power supplies, the 6632B power supply here, to measure the inrush current, peak inrush current actually, which occurs at turn on. So I've already turned on the power switch for the power supply. The rail voltage, the DC caps inside the unit are fully discharged, because this is when you're going to get the worst case inrush, is when the capacitors are at their lowest voltage, essentially zero. And what I've already done over here with our AC6800 family power AC source is I've already set it up for the correct input voltage, frequency, and I've already determined that the worst case inrush current happens at 70 degrees phase angle. And this can be set to any phase angle you want over here using our function keys, where you can set the output phase at turn on. So you can actually synchronize the output turn on to be at any degree between 0 to 360 degrees. So I've actually chosen 70 degrees in the screen here. So all I have to do is say enter and go back to my screen, and this is all set so that when I turn on the AC source, it'll come on at exactly 70 degrees phase angle and measure the peak inrush current into my circuitry over here. So I'm going to go ahead and start the test. I set output on. You can see the unit over here is booted up, and over in the screen here, shown below, is the actual peak current inrush, and that's a hold function, so it actually measures the peak current that's occurred at any time during the last cycle until I clear that number. So at this point I can turn it off, and you can see that the rail voltage over here has to discharge. In order to repeat this, I have to ensure that the capacitor is fully discharged before I do it again if I want consistent and repeatable measurements. Basically, this makes it very easy to do this in a production setting, where you can do this once the unit's been built, properly assembled and tested. You can ensure that none of the features are working incorrectly. I also have some other power supplies I'd like to show you in a moment, which have different inrush limiting topologies, and I'll talk a little bit about those. So here are two additional power supplies that we also make that use different inrush limiting topologies. The first one that we just tested is a straight linear, which basically has input inductance in the transformer, which helps limit the peak inrush current. The next power supply shown has an NTC, which is a negative temperature coefficient resistor on the AC input line. And what that does is when the resistor is cold, it has a high resistance value, so that when you first turn on the power supply and the input caps are discharged, it limits the inrush current to a reasonable value. Once that resistor heats up in use, that resistance drops to a very low value and it doesn't dissipate a lot of extra energy in the box. The third power supply I have shown here uses a resistor to limit the inrush current, but then has a relay which shorts out the resistor once in operation to reduce the power dissipation in the box again. Both of these boxes here and here can have trouble with the inrush limiting resistor. Either the wrong value has been put in, or in the case of the top one, they could actually have forgotten to put the resistor in, or the resistor could be internally damaged and not functioning at all. So the unit would still turn on, but would have a huge inrush current, which you would then be able to catch with our AC source in production testing. So that kind of wraps up the ability of our AC source to do inrush current limiting. I hope this has been helpful.